Hi, my name is Sam Drake. I'm an architect in Oracle TimesTen in-memory database development. I'm going to talk to you today about the architecture and concepts for TimesTen Scaleout. Now, as I mentioned earlier, a grid supports one or more databases. You can have either 1, 2, 3, or however many databases you want in a single grid. Each of those databases is completely independent. They have separate users, schemas, tables, data. Data may be distributed in slightly different ways across those databases. We may refer to in this talk the database in a grid. That's really just a shorthand. What we really mean is a database in the grid. There can be 5 databases in a grid or whatever number the user would like to have. As I mentioned earlier, databases are internally split into what we call elements. Every data instance in the grid has an element of every database in the grid. So in this example, you can see we have 2 data instances and 2 databases for a total of 4 elements. Right? Each instance contains an element of each database in the grid, and each database has an element on every instance of the grid. Each of those elements stores a portion of the data from its database, and we'll talk more about what portion that is. And again, the point is all the data in a database is accessible from everywhere, regardless of which element it's actually stored in. In TimesTen 18.1, the maximum number of elements per database is 64. So what's inside of an element? Well, we're going to look at that from 2 different perspectives. There's a physical view and kind of a logical view. And as a physical view, an element is kind of an independent thing. It stores a portion of the data from the database. It has checkpoint and log files on local storage in the instance, which are used to make the instance persistent and recoverable. There's shared memory into which the database is loaded when it's in operation. There are a number of background processes in the data instance that manage that element. This should all sound pretty familiar to you if you've used TimesTen in the past. If you think about TimesTen Classic or just TimesTen in previous releases, everything I just described is what in TimesTen Classic we call a database or a data store, right? With checkpoints and logs and shared memory and all of that. And that's exactly what an element is. An element of a database in TimesTen Scaleout is what in TimesTen Classic we would have called a database, with everything that goes along with it. The same recovery mechanisms, the same subdaemons, and all of that stuff is still here exactly as it is in TimesTen Classic. And that's what an element is from a physical perspective. Now, from a logical perspective, each element contains a piece of the database. Now, which piece does it have? Well, to start with, each element contains the entire schema of the entire database. So every table in a database is present in every element of the database. It may, which rows of that table are in each element, we'll talk about in a minute. But the schema is there. All the user information, all the metadata is there. User IDs and passwords, schemas, tables, views, sequences, all the sort of database objects you can create in a database. All of that information is present in every single element. So now let's start to talk about what data, which rows of each table are present in each element. And that's a topic we'll call data distribution. As I said, all tables in a database are present in every element. Now, when a user creates a table, they define a distribution method for that table. The distribution method of each table in a database may be different. There are 3 different methods that we support in the first release, and different tables in a database can use different methods. The distribution method describes how rows of the table are distributed across the grid. In TimesTen 18.1, there are 3 supported distribution methods: hash, reference, and duplicate. And we'll talk more about what those mean in the next couple of slides. Probably the most commonly used distribution method for tables in TimesTen in a TimesTen grid is distribute by hash. And in fact, it is the default distribution method if the user doesn't specify one. In a hash-distributed table, a given row is present in 1 or 2 elements chosen by the grid. And basically the primary key will be hashed, and based on that hash value, the row will be placed in one or two elements that match that hash value. So if you've got a primary key of 1 may be stored in element 1, a primary key of 2 may be stored in element 2, etc. The idea is that the rows of the table will be distributed across the elements of the grid in a more or less even distribution, with about the same number of rows being in each element of the grid, but each row being present in only one or two elements of the grid. And that's the fundamental way in which we take a single database and distribute its data across a large number of instances, is by hash distribution. As I mentioned, hash distribution is the default distribution method. Oh, you can do this by primary key, and that's probably the normal case, but you can also specify a separate distribution key if you'd prefer. As I said, hash distribution is the default distribution method if you don't overtly pick one in your create table statement. It is probably appropriate for most tables. We think it'll be the most commonly used distribution method in the grid. And it uses what's called a consistent hash algorithm, meaning that if you have a particular primary key, we can just look at that primary key and figure out where it should go. As far as how you specify the distribution key, or the distribution method for a particular table, you do that in the create table statement. And there's an example here in the slide. So we create customer and we define a primary key and put in some fields. And then at the end of the create table statement, we say distribute by hash. Or since it's the default, if we didn't say anything, it would automatically be distributed by hash. The next distribution method we'll talk about is distribute by reference. Distribute by reference is used in parent-child environments. The idea is, suppose you have a parent table like customers, and you have a child table, for example, orders, where every customer places some orders. The customer is the parent and the orders are the children. Distribute by reference allows us to place the orders that were placed by a particular customer on the same element as the customer itself. You can imagine that would be appropriate if you're doing lots of joins between the order table and the customer table. You may want to find all the orders that a particular customer placed. If that customer and all of his orders are present in the same element, then that joins very fast. It doesn't involve any network traffic. We don't have to go from one element to another to get the appropriate set of orders for a given customer. And so distribute by reference lets us do that. In this example, we have the customer table. The parent table is distributed by hash. So customers are spread uniformly around the grid. All of the orders for an individual customer are present on the same element as the customer. They're distributed by reference. We have a foreign key from the order table to the customer table that describes it. And so when you say distribute by reference, we'll automatically follow that foreign key and place the orders for a particular customer in the same set of elements that the customer itself resides in. So here's another example of that, of a distribute by reference environment. So we have, in element 1, we have customers 1, 10, 44, and 63. We also have all the orders that were placed by customers 1, 10, 44, and 63, and also in element 1. Where in element 2, we have a different set of customers, and the orders that were placed by those customers are located in element 2. The third distribution method that we support in TimesTen 18.1 is distribute by duplicate. And this is a pretty simple one. If you define a table as distribute by duplicate, then every row in the table is present in every element of the grid. Now this is very appropriate for reference data, right? Tables that are relatively small, frequently read, and infrequently modified. In this example, for example, I've chosen a tax table, right, where we're constantly looking up the tax rate for a particular state as we're processing orders. But those tax rates don't change very often, maybe once a year or something like that. And so that's a small table, constantly read, very infrequently modified. And so it's a perfect candidate for distribute by duplicate. Again, that way, that'll minimize network traffic. If we're doing a join, the data is always there so we can read it without having to hop across the network to fetch the appropriate data.